Welcome back to Code with Festus, where ideas turn into code. In our previous videos, we successfully installed Python and set up your development environment. You've got the engine running, but now it's time to learn about the fuel that powers it, data. In this video, we're diving deep into Python data types and variables. These aren't just academic concepts, they are the absolute DNA of every program you will ever write. Whether you're building a simple calculator, a web application, or a high-level artificial intelligence, you will be using these concepts every single second. By the end of this video, you won't just know what a variable is, you'll understand how Python manages memory under the hood and how to choose the right data type for the right job. Before we talk about data types, let's clearly understand what a variable actually is. Imagine you're moving into a new house. You have a lot of stuff and you put that stuff into boxes. To make sure you find your things later, you take a marker and write a label on the box. The kitchen, supplies, drawers, and books. In Python, a variable is that label. The stuff inside the box is the value, and the box itself represents a specific location in your computer's memory. When you write x equal to 10, you are telling Python, hey, take the number 10, put it in memory, and give it the name x so I can find it later. In Python, creating variables is incredibly elegant. Unlike other languages like Java or C++, where you have to explicitly tell the computer, I am about to store an integer, Python is dynamically typed. You just assign a value using the equal sign, and Python is smart enough to figure out the data type for you on the fly. This automatic detection is why Python is the gold standard for beginner friendliness. It lets you focus on solving problems rather than managing complex syntax. Now let's explore some of Python's data types, starting with primitive data types first: numbers, integers, and floats. Numbers are the bread and butter of programming. In Python, we primarily deal with two types: integers and floats. Integers are whole numbers. They don't have the decimal point. Think of things that are countable in the real world: the number of players in a game, your age, or the year 2026. These are all integers. Floats or floating point numbers are numbers with decimal points. These represent measurable things: the price of a gallon of milk, like $5.99, your GPA, or the precise value of pi in mathematics. In Python, you can perform math across these types seamlessly. If you multiply an integer by a float, Python will automatically return a float to ensure that the result stays precise. This flexibility allows you to perform complex calculations without worrying about breaking the math. Strings. Most of the data we interact with daily is in numbers, here is text. In Python, text is called a string. Think of a string as a literal string of characters tied together. To tell Python that something is a string and not a command, we wrap it in quotation marks, either single, double, or triple quotation marks. However, triple quotation marks for a string is less common and could have other meanings depending on where it is used. Whether it's a single letter like A, or full sentence, or even a long paragraph, Python treats it as a string. Strings are used for everything: username, email addresses, the text on the submit button, or the contents of a digital book. One cool thing about Python strings is how many built-in tools they have. You can easily make them all uppercase, replace certain words, or check if a string contains a specific letter. You'll be interacting with strings constantly, especially when building web apps or processing user input. Booleans: true or false. Computers are fundamentally built on switches: on or off, 1 or 0. In Python, we represent this logic using booleans. A boolean can only ever be one of two values: true or false. Note that in Python, this must always start with a capital letter. Booleans are the decision makers of your code. They track conditions. Is the user logged in? True. Is the shopping cart empty? Pause. Is the game over? True. Why they seem simple? Booleans are the foundations of control flow. In our crash course and even later in this series, we'll use Booleans to tell Python, if this condition is true, do this, otherwise, do that. The data types we've looked at so far, numbers, strings, and Booleans, are called primitive data types. Now let's look at composite data types. So far, we've looked at variables holding one piece of data, but what if you have a collection of data? That's where lists come in. A list is an order collection of items. Imagine a grocery list or a list of high scores in a game. You define a list using square brackets, and you separate each with a comma, just like the example shown. Lists are mutable, which is a fancy way of saying they are changeable. You can add new items to the end, remove items from the middle, or swap one item for another. They are incredibly versatile because a single list can hold a mix of different data types, like a string and a number together, even another list. You can retrieve item in a list using index of that item in the list. In Python, like other programming languages, index starts from 0. Therefore, to retrieve color green from our colors list, we use colors, open square brackets, 0, close square bracket, where 0 is the index location of green. To retrieve red, we use colors, open square bracket, 2, close square bracket, because counting from index 0, the index of red happens to be 2. If index started counting from 1 instead of 0, it would have been colors 3 for red and colors 1 for green. Dictionaries, sets, and tuples. Sometimes a simple list isn't enough. Sometimes you need to map one piece of data to another. For that, we use dictionaries. A dictionary stores data in key value pairs. Think of a real-life dictionary. The key is the word you look up, and the value is the definition. In code, you might have a dictionary for users, where the key, user's name, maps to the value, user's full name. Dictionaries are defined using pair of curly brackets. The example on the screen shows dictionary definition. Unlike lists, to retrieve items in a dictionary, we use the named keys of that dictionary. In our example, Festus and CWF are keys of the dictionary, while Festus Ali and code with Festus are values of those keys respectively. Hence, to get the name of code with Festus, we use student, open square bracket, string quotation, CWF, close string quotation and close bracket. And to retrieve Festus Ali, we use student, open square bracket, open string, Festus, close string, close square bracket. Then we have sets. Sets are like lists but with two major differences. They are unordered and they only allow unique values. If you try to add the number 5 to a set that already has a 5, Python will simply ignore it. Sets are perfect for when you need to filter out duplicates or check if an item exists in a massive collection very quickly. Similar to dictionaries, sets are defined using curly brackets, except that it's not by key value pairs. Rather, the items are separated by commas just as in lists. Here's an example. Lastly, we talk about tuples. Tuples are almost identical with lists except they are immutable, meaning once created, the values can be changed midway as we would a list. They are also faster than lists. You can use it in instances where you want to create a list of things that doesn't change. The example on the screen is how to create a tuple. These are not all the possible data types in Python. There are still more, including range for sequences of numbers, bytes and bytes array for binary data, frozen sets for immutable set, non-type representing no value, custom classes, user-defined data types, and many more. However, you will learn more about them as we progress. Use cases for each collection. You shouldn't feel overwhelmed by these concepts. Just keep these use cases in mind. Lists and when to use it. You need an ordered, changeable collection, storing items in sequences, example, tags, names, results, frequent insertions, deletions, or updates. Tuple, when to use it. When data should not change, like coordinates, config values, returning multiple values from a function, using as dictionary keys. Dictionary, when to use it. You need labeled data, past lookups by key, representing objects, user profiles, settings, JSON-like data. Set and when to use it. Removing duplicates, faster membership checks, mathematical operations, union, intersection, differences. Checking types and updating variables. As your code gets more complex, you might forget what kind of data is stored in a specific variable. Python provides a built-in magnifying glass called the type function. By typing type open brackets followed by your variable name inside those brackets, Python will tell you exactly what it is, be it an int, string, list, or any of other possible data types. Finally, remember why we call them variables. It's because they can vary. You can assign the value 10 to a variable named score, and then 5 minutes later, update score to 20. This ability to update and change data as the program runs is what makes software dynamic and interactive. You've just taken a massive step into your coding journey. You now understand the containers, variables, and the content data types that make up the world of Python. From the simple logic of Booleans to the structured data of dictionaries, these are the tools you will use to build the future. Take a moment to practice. Try creating a few variables on your own. Create a string for your name, an integer for your age, and a list of your favorite hobbies, or who knows, a tuple of your exam scores. In our next video, we are going to put this data to work. We'll explore control flow, learning how to make Python think, and make decisions using if statements and loops. I'll see you in the next one. Happy coding.